Now that we've had the opportunity to learn about piecewise functions, we're going to look at a piecewise function that most people probably know already, but do not realize that it's a piecewise function. And that's the absolute value function. And so the absolute value function actually looks like this as a piecewise function. So if I said f of x equal to x or negative x, but over a range of x values, so for x we want all of the x values greater than 0, we could say equal to 0, and for negative x we want all the x values less than 0. And so that would create this situation here where we have part of the diagonal going up that way, and then we have the other diagonal coming this way, and so that would create those two lines meeting at a point of 0, 0, which we're going to call our vertex. And so that point where they meet is going to be the lowest point on the graph, what we call a minimum or a vertex in this case. And so that's really, absolute value is really a piecewise graph. Now, in general, we've learned that the absolute value looks like that, and so that basically means the same thing as the piecewise function up above. And so we know that absolute value means that we can't have a negative number. Whenever we plug a value in for x, we're going to get a positive number out of that absolute value. And so this is the graph that it creates. So you can look at the absolute value graph and you can think of it as a parent function. If you recall our previous parent functions, they all tended to move around the coordinate plane similar. So they can shift left to right, or they can shift up and down, which is called translations. They can also reflect over the axis or a line and have line symmetry. And so there's a number of different things that acts the same as our prior parent function. So what we're going to do for this verse video is just go through an exercise of recognizing all of the different translations that we've done prior to this and see how they work with an absolute value function. So you can always know that an absolute value function is going to make a v and come to a point called the vertex, and so that's going to be pretty consistent. For the parent function, y equals x, you could also think of it as f of x equals the absolute value of x, is always going to be a vertex at 0, 0, and then it's going to have more or less a positive 1 slope on the positive part and a negative 1 slope on the negative part. And so what we want to do here for sample problem number 1, what I would like you to do is to go ahead and graph y equals to the absolute value of x, then graph y equals negative absolute value of x, and then tell me what's changed from the original parent function to the part B function. So go ahead and take your time and do that right now and come back and check out the answer. Okay, so hopefully you're able to graph these two parts A and B, the functions absolute value. So I'm going to go ahead and do this. Now, you should recognize that for the parent function of an absolute value, our vertex is going to be at 0, 0. And on the right side, on the positive values of x, it's going to have more or less what you would consider, what some of y'all would recognize as a positive slope again. Straight edge is always very useful doing this. So just do the best you can on the computer. If you're doing it on paper, use your straight edge. And then the other side actually has a negative 1 slope to come together at that vertex of 0, 0. And so that's the parent function of an absolute value graph. Now, for y equals negative absolute value of x, what we can do is we could actually t-chart this if we wanted to. And so we could t-chart negative 1, 0, and 1. And of course, if we plug negative 1 into the absolute value of x, that gives us a positive 1, but then we end up negating that positive 1. So that puts us there. 0 is going to give us 0, which gives us the same vertex. And 1 is also going to give us negative 1. And you can see the trend here that this is actually going to go down at that slope and down at this particular slope, and it creates a reflection over the x-axis. And so that negative value in front of the absolute value is very similar to when we had a negative value in front of the quadratic. It just flips it over the x-axis, the exact same point. So it's got symmetry over the top of this line. So now, as we move into the next part here, what I'd like you to do is I'd like you to do C and D, and when you are dealing with the question, what changed? What I really want you to answer is what changed from the parent graph. So that original parent function like this, make the assessment as to how it moved according to that one. So go ahead and take your time and do that right now. Okay, so I've gone ahead and graphed these two graphs on here, and you can see from my red graph, I'm going to go ahead and highlight this so it's a little easier to see. So if I could draw straight, that would be the parent function of the absolute value. And so you can see from our red graph, what's happened is that this value in here inside the absolute value made the graph actually shift 2 units left. And if you remember from when we did translations in Unit 1, it was a similar effect when we had that value inside the parentheses with the x. It shifted it 2 units to the left. So it's going to have the same effect with the absolute value. Now, you can see here, 2 in front of the absolute value. It had a similar effect as having a multiple in front of the parentheses in Unit 1 as well. And so what it created was a steeper graph, and so this is a dilation, and so this kind of pinched it in a little bit, made it a little steeper, brought it a little closer to the y-axis, and so instead of going a 1-for-1 type slope, it actually went over 1 and up 2, create a steeper graph. Okay, so let's just do this one more time. Again, graph the following parts and see if you can assess what has changed in relation to the parent function, and then for part F, maybe if you can recognize the patterns, you could go and do it all in one swoop without using your calculator. Okay, so hopefully you had the opportunity to do part E and F. And what I'm going to show you here is part E is in red, and you can simply see that adding 3 outside of the absolute value bars just simply makes the graph slide up 3 units. So we shifted that up 3 units. Now, hopefully you're starting to recognize that in this particular case, the 2 inside the parentheses is going to shift it 2 to the left. The 3 outside the parentheses, or excuse me, the absolute value bars, are going to make it shift 3 up, and then of course the negative sign is going to make it flip, thus giving us a shift of 2 over 3 up, which gives us our vertex there, and then I'll now know it's going to be upside down. And so that gives us our final graph.